And now we come to what is arguably my favourite case study of the entire GCSE geography course. Why? Well, because everything about it sounds so bizarre. First of all, it's in a place called Chungungo in northern Chile, which totally makes like or sounds like a made up place, but it's not, as we'll see. Secondly, what they do there to try to use some appropriate technology also sounds utterly bizarre. This is one of the driest places in the world. The Atacama Desert's not the biggest, not the hottest, but it's certainly one of the driest places in the world. In the Atacama Desert itself, there are places where there has been next to no meaningful rain in thousands of years. Thousands of years. And the reason why we can see that is whenever you go up into these hills above the villages and the coastal strip here, these hills are made of these kind of boulders and rocks and things like that go down them. And some of the locals that lived there in the past, some of the indigenous peoples that lived here thousands of years ago, their art was to put onto these slopes some boulders that they arranged out in these beautiful, huge displays of art. Now, if there'd been any kind of meaningful rain here at all in the time since then, of course, the gravelly slopes would have eroded away and the art would have been taken away with them, but they haven't been, they're still there. And indeed, what you can get in these slopes is something rather sinister and creepy and bizarre. Sometimes if you go up, climbing up the side of one of these little slopes, if you go up the gravelly side here and you're maybe putting your hand on one of the rocks to help you up, and you realise actually when you put your hand in the rock that it's not quite as rock-like as you would think. And the gravel starts to fall away from the side of it, and you realise actually as you reveal more and more of the rock that there are two eyes staring back at you. Because what you have just revealed is a naturally mummified person that was buried there maybe thousands of years ago. The climate here is so unbelievably dry that decomposition doesn't really happen. Instead, what happened to the people that were buried in these slopes was that they naturally desiccated and dried out. Now, if you've ever gone to the Ulster Museum in Belfast and had a look at the Egyptian mummy there, that was done by the Egyptians carrying out that process, you will know what this looks like, the dried, desiccated, weathered skin, but the skin still is intact. And that's just another indication here of just how unbelievably dry this location is. Okay, but the location, whenever it's dry, is still somewhere where people live. So how do we get water if you're living in this area that is really unbelievably dry? Well, let's go and have a look at this. Here is Chungungo, the village itself. It's situated in the northern Chile beside the Atacama Desert, the driest in the world, as I said. Chungungo here, because it's by the coast, gets on average about 60 millimetres of rain per year. Now, bearing in mind that Lurgan, Northern Ireland, gets around about 900 millimetres per year, and this is very, very dry, as you can see. So up until 1992, the village's water supply had to be brought inland and road by tankers, which meant then that their supply was very, very limited, only 15 litres a day per person for everything, for drinking, for washing, for cooking, for everything. And it was also unreliable. If we take a wee look here at just one of the roads, this is one of the main roads in towards Chungungo, right? This is the main road. Are you ready for it? So when we talk about this village being remote, this is the main road, the D190 that the tankers were meant to come and visit from. And if we just zoom out a little bit here, you can see some of these roads as they weave their way down from these narrow winding roads. How difficult that would be and how remote and inaccessible that would make this little village of Chungungo. So in that context, let's go and have a little bit of a look at Chungungo to get a bit of a sense of it here. This is not only remote, but it's also a place where there is some considerable poverty. If you look at that, well, they have some basic services. Yes, they do have some electricity and some buildings there, but if you look at this village, it does just seem very, very remote, very isolated. And certainly there's evidence that this is not an area that's particularly resource rich, particularly wealthy. So what does appropriate technology look like here to try and get these folks some water? Here we go. So there may not be a lot of rain here in Chungungo, but on the hills above Chungungo, many days, in fact around about 200 afternoons per year, the water comes off, or the air comes off the ocean here, the Pacific Ocean, and blows over the land. As it meets the hills, it rises, cools and condenses to form fog. Now, it doesn't rarely get to the point where the clouds are sufficient enough to cause rain to fall, but cloud droplets, the fog are droplets of liquid water. So there is liquid water there. So how do you get that cloud turned into usable water for the people in the village? Well, it's relatively simple, it turns out. You just take these nets, and as the fog comes through the nets, the droplets of water deposited onto the nets, they go into the bottom here, and they just go down using gravity, flow down here through pipes into the village. So what they did in Chungungo was place 90 of these large nets up here to harvest water from the fog. Absolutely amazing to see. Now, let's have a wee look at a video of that to see exactly how that fog harvesting works.
Gideon Long is in Chile to see what they're doing there to increase the supplies of fresh water.
From bone-dry deserts in the north to rain and snow in the south, the weather here in Chile is extremely diverse. Some areas get no rainfall at all, making getting water for crops a huge challenge. But here at the Catholic University in Santiago, scientists may have an answer, and it involves collecting water from fog. The idea of catching fog in a net may seem as fanciful as catching a wave upon the sand, but it is possible, and it is happening around the world. Here in Chile, Juan de Dios Rivera is a global expert who's aiming to perfect fog collection to bring much needed fresh water to poor, isolated communities. So once you've collected the water from the fog, what can you use it for?
Anything. It's fresh water, so you can use it for drinking, for any household use, for irrigating plants, and even for industrial purposes.
This is not a new technology, and it's been developed in other countries in the world as well. What's different about what you're doing here?
We're focusing in producing water in large quantity for larger community, focusing on providing to poor community in very isolated areas.
I want to talk a little bit about the potential for this technology. How useful could it be?
We think that it can be very useful. There are many places in the world where you will find lack of sufficient fresh water and also the presence of this fog.
And how much could it mean in terms of saving for farmers and who don't have to find other ways of irrigating their fields?
Well, our benchmark is seawater desalination. We think that fog water should be less expensive than seawater desalination.
Research into fog harvesting is carried out in Chile because here, part of the Atacama Desert hasn't had rainfall for hundreds of years, but it does get plenty of fog. Juan chooses his test sites in locations that are remote and where people need fresh water the most.
Today we are in Majada Blanca. This is a site close to La Serena. Here we have 3 large fog collectors in which we collect water for watering a plot of land we have down below in the valley. This is a Rachel mesh woven with a round filament, and the little thread will collect the water, the droplet from the fog, and by gravity, the droplet will roll down and fall into this trough. So this trough will collect all this water and bring it down to a pipe that will drive it to a water tank where we store it for later use. We are very close to the ocean, to the Pacific Ocean, and over a large expanse of the Pacific Ocean forms a stratocumulus cloud. This cloud is pushed toward the continent by the prevailing winds, and when it hits a mountain high enough, it turns into fog. So this area in which we are standing now, the plants that live in here, they collect water from the fog that helps to survive. The plants here are doing the same job we are asking from the collector. So we study the plants to learn from them how to be more efficient in collecting the water. In this moment, we are in the plot of land. We are watering with the water from the fog collectors, with olive trees, grapevines, and also another kind of tree called Acacia saligna. In this moment, the future is a bit uncertain because it depends a lot on the people of this community. At the present time, all this valley of this area is of no use to them because of the lack of water. So if they are convinced that it's going to be a good business for them and they could make out a living of farming this land with fog water, then this project will grow and will become a very useful thing for the people.
So while that was just one test site, it's Juan's ambition to make fog harvesting a useful and viable option for the masses. So once you've got the design right for this mesh, could you in theory build one 100 meters across? How big can you go?
We think that there is no limit. Imagine, for instance, two mountains, okay? And maybe we could drive a cable from the top of one mountain to the top of the other one, and from there we could hang a very big mesh.
So you just drop a mesh over an entire valley and collect the fog as it comes through the mesh?
Yes, this is the concept.
So this is an old technology that's been around for some time. How long do you think it will be before you perfect it?
We always have the analogy of wind turbines. Wind turbines 50 years ago, they were small windmills. But in the past 50 years, the technology has been developed, and now we have huge wind turbines.
Can you imagine a situation in the future where we have fog-collecting farms?
Absolutely, yes. We are aiming for that scenario.
Interesting to see towards the end there when they're talking about scaling that up to use it kind of like fog collecting farms. But the start of the video is really looking at how it's being used in this very small scale at the moment to support villages like Chungungo. So you can see how that's appropriate technology. It is very, very easy to maintain in terms of the skill level of the local. It's not that expensive to set up. And it is very, very much suited to the local conditions, modelled in many ways off the plants that have adapted there to be able to harvest the water directly from the fog themselves. Right, we wrap this case study up by taking a look at an evaluation of how effective this is. This is what the specification asks us to do. What are the pros and cons? You remember within evaluation, you need your pros, you need your cons, and then you're going to finish with a conclusion. Okay, so here are some of the pros. It gives you some information here about 170,000 litres of water to the village per day. Now remember, the people were limited here to 15 litres per day. This is increasing their water consumption by twofold. It's doubling it to 30 litres per day. In the first 10 years of collecting it, the village grew from over 300 to 600 permanent residents, and many more coming in this summer. It also brought tap water to the locals. They previously had to collect the water from a water tank in the village, and it could be used for a variety of purposes: drinking, irrigation, forestation, as they saw there, and there were no negative environmental impacts from this. This is not damaging the environment in any meaningful way. It's a very, very sustainable way of doing it. Looks like it's brilliant, doesn't it? There are some cons to it, though. The nets in the first instance didn't supply all the water the villages needed. In fact, 25% of their water still had to be brought in by tanker. And of course, as more people were attracted to the village because of the water supply there, the village grew. There were more people than the nets could provide water for. Secondly, the water supply wasn't as reliable as they needed to be. In 1997, there was a big storm, and 10 of the 90 nets were destroyed by that. Now, it took 15 months later for these to be replaced, leaving the people reliant more again on the water tanker. Was not able to keep up with demand of the local people. Now, partly because of that, because of the issues of reliability, the local people began to become a little bit more sceptical about their use. The fog harvesting nets, it seemed to promise so much, didn't quite deliver on what they promised. So the local people stopped really maintaining them as much. They fell in disrepair. Parts were stolen, so by 2002 only 9 of the 90 nets remained intact. So the application of this perhaps wasn't as good as it might have been. And that brings us finally to our conclusion. So here we are, our lovely little village of Chungungo, isolated, needing a supply of water. Based on what you've just heard, you can finish off your case study by writing a conclusion. What is your view of the effectiveness of this as a strategy, as an appropriate technology strategy? So that is the case study of fog harvesting in Chungungo. Once you've finished watching this video, the next thing you need to do is to go on to the questions in your books just after that and have a go at answering those.